Okay, so the first word arrangement. So certain data will be given, certain balls will be given, certain it could be a certain things would be given, and that things we need to arrange. That things we need to arrange. It could be row wise or in a we need to arrange that particular given things in a single row. So suppose there are four things A, B, C. So we can arrange A, B, C, B, A, C, or C, A, B. Or so suppose this arrangement have a certain position base. So most important thing would be in a for arrangement is a going to matrix position where that particular thing is going to lie, where that thing is going to have a position. So arrangement alternatively also called as a position. So alternatively arrangement is also called as a position. So position is going to matter. Those only three things. Every situation there are only ABC. Every situation there are only ABC, but we have done the arrangement. So either it could be A at the first, B could be at the first. So we can do the this arrangement also. A, C, B also. Then B, C, A also. Then C, B, A also. Okay. So 1, 2, 3, 4, 5, 6. So 6 different arrangements can be possible using this particular three articles, three things. We can say three things. It could be balls, colors, it could be anything. So by default, it could be a different things. So using these three things, we can arrange manually admin 5, 6 arrangement are possible. So whenever this kind of arrangement question asked, and we need to arrange the particular things, then we have to matter the position. Why I am focusing on the position is that because this P means position. Just to remember the particular how what we are going to do is in a permutation position is going to matter. In permutation position is going to matter. Position means arrangement. So whenever there is a question of arrangement, then whenever there is a question of arrangement, we have to arrange a certain things. Then definitely we have to concentrate on the permutation. So there is a formula for permutation. So suppose there are n particles, n possible particles are there, and we need to select R. Select R means R things are selected, and we need to arrange. So that NPR it could be written. So the permutation of n things where we have selected R things, then it could be called as n factorial minus n minus R factorial. Okay, n factorial minus divided by n minus R factorial. This formula is useful for where? This formula is useful for the arrangement part. Whenever we are going to do a certain arrangement of the given things, then we are going to use this formula. So whenever the question asked and there is a certain position matter, arrangement, a certain kind, this kind of word is given there, definitely we have to use this kind of formula. So what the formula represent? N things are there. N things are there. It could be color, anything. What are the balls are there, or it could be certain chocolates are there, or whatever, and what the things that can be separated to each other, not the similar thing. Okay, so that from the N things we have selected R. R selected. So here 3 balls were there, 3 names alphabets were there, and 3 alphabets all were selected, and they are arranged. All alphabet we have selected and we have arranged. So similarly, suppose I can write the second part here. Permutation where position is going to matter. Position means arrangement. This is the first case where n things are there and are selected. Suppose there are 5 balls are there, 5 balls are there, and we have selected 3 balls, and we need to arrange. Obviously, it is suppose that both all are different color. Then only it will be possible. If there are some balls are similar color, it will not be possible to arrange them because same color is going to matter. That formula I will explain also. Okay, so there are 5 balls and 3 balls selected, and 3 balls we need to rearrange. So we can write 5p3. So it would be 5 factorial divided by 5 minus 3. It would be a 2 factorial. So the formula would be 5 into 4 into 3 into 2 factorial. So 2 factorial will be gone. So it will be 60. I think something is wrong. Okay, so using that particular 5 things, we can do arrangement of that particular 60 times. So 60 times can be possible. Okay, now consider things where all things are selected. Young things are there and all things are selected. Young things are there and young means R is could be young. R is here young. All things are selected. What will be the difference on the formula? What will be the formula? What would be the formula? Anybody can suggest me? If all things are selected, what will be the so basically it would be formula would be n p n factorial divided by n minus n. It would be 0 factorial. That means n factorial. Then this number of times arrangement can be possible. Right now, so these are the formulas. N things n selected. That could be n factorial. Is it okay for you? N things would be there, and n selected means all selected. Whenever you select all things, then the permutation or the arrangement could be possible n I factorial times. N I factorial times number of arrangements can be possible if all things are selected. Okay, so now obviously I have said that whenever these n things are there, it should be a different, means each thing is different to the another one. So all things are alike. All things are alike. All things are alike means no things are similar to each other. In the n things, all things would be different, not similar to each other. Now, some question arise or some situation arise where some things would be, some things or some that particular things are similar to each other. In the n things, there could be a 5 balls black, 5 ball black, 4 ball reds. So suppose there are 9 balls and 9 balls are not similar, means all are not similar, but certain situation arise where some balls would be same color and some balls would be different color. So this formula can be applied if 9 balls all have different colors. All are different colors. But then we can apply this kind of formula. If these particular balls are not similar color, then we have to apply a different formula. So in that particular young things will be there. There is a n1 are similar. N1 I will say. N1 are similar. Then what will happen on the arrangement? How many arrangement can be possible? How many arrangement can be possible? How many arrangement can be possible? How many arrangement can be possible if number of permutation of the n object taken all at times and denoted by p, where n1 objects are identical and others are distinct. Others are distinct means others are not similar. So their permutation can be considered as n factorial divided by n1 factorial. N factorial divided by n1 factorial. Okay, so if that particular n things are similar, suppose there are n1 is a certain position, a certain distinct group, n2 is another distinct group, n3 would be another distinct group, so that n is n1 plus n2 plus n3. Then just we have to do the certain arrangement that P would be n factorial divided by n1 factorial into n2 factorial into n3 factorial. So number of things are similar, just we have to divide. Just we have to divide. That much change we need to do. That much change we need to expected to do here. Okay, have you got any question or any query you want to ask me, whether you have got this or not? Why Aniket has started the lecture? I can see clearly seen the somebody has started the lecture there. Any question? At least respond with a type yes. You need to solve the problem. Once I have explained the things, it is expected to solve the problems. There is a very few people are there. If you got this, type yes. If you got these particular things I have explained here, type yes, so that I can take a few problems based on this. At least somebody should type yes. Okay, I think all are in a deep sleep. So suppose we will take a problem, one by one problem we are going to take. I think we have forgotten the one situation also. So always I force situation where we need to arrange a certain things in a circular manner. N things are there, R are selected. N things are there and R things are selected. Then what would be situation? Circular permutation. Circular permutation. Okay, so circular permutation can be n minus I factor. N things are there and all are selected. Suppose all are taken. N things are there and all are taken. It is called as a circular arrangement. So these are the four formulas that are sufficient. 1, 2, 3, 4. That will be sufficient for covering all problems based on the permutation. So these formula, if you cover, if you listen, if you practice, based on this, all the problems are there in a permutation. Okay, so we'll take a few problems. If it is a possible, type yes. Pervez type yes. Okay. So take the problem. There are 6 candidates. I will write the problem here so that you can consider this problem. We don't have a time to write the problem. I will read out the problem and we will make a solution. There are 6 candidates contesting a certain office of municipal election. In how many ways can their names are listed on a ballot paper? So basically there is a ballot paper is there, and they are given 6 candidates are there. 6 candidates are there. And they have said how many ways these candidates can be arranged. So these six candidates are there. So how many ways these six candidates can be arranged on a ballot paper for certain election? If they have said, they have given the information that there is a certain office in the municipality and there is an election. So how many ways it can be possible? If you read out the particular problems, there are six candidates contesting the for certain office in a municipality. In how many ways their names be listed in a ballot paper? Okay, so seeing the particular problem or just reading out the particular problem, you can see there is a we need to do names, candidate names are there, and we need to arrange these particular names. We need to do arrangement, or these names are, it could be at the first position, second position, third position, fourth position, fifth position, or sixth position. So arrangement or either position is going to there. So when this particular arrangement and position going to be there in the particular problem, definitely we are going to use a permutation. We are going to use the formula, because as we read out the particular problem, we can see there is an arrangement of the certain position is going to matter. Okay, so next information is what the six candidates are there, and we need to arrange. So obviously six candidates are there, and it is implicitly meaning that all candidates are there. All candidates we have to select and we need to arrange. So six candidates are there. Six candidates we need to select. So NPN. So we can use the formula this way. So NI, that means 6 factorial. So 6 factorial means 6 into 5 into 4 into 3 into 2. So that is 720. So it could be possible, means these particular names can be arranged. So answer could be 6. The arrangement can be possible by using 720. 720 वेळा it is possible. 720 वेळा ते नाव आपण वर खाली लिहू शकतो. Is it okay for you? 6 candidates are there, and 6 candidates are selected, and we need to arrange their names on the ballot paper. Okay, so that can be possible by using 720. We have done the 6PC, 6P6, that means 6 factorial. Use the second formula, that means 720 is a possible thing. Okay, some interesting problems would be there. So we'll take a problem based on. So I will read out the second problem. 6 candidates are called for the interview to fill the 4 posts. 6 candidates are there. Now 6 candidates are there, and 4 posts are there. 4 posts are in an office of, assuming each candidate is a fit for the office. For the each post, determine the number of ways which first and second post can be filled. First 3 posts are to be filled, and all 4 posts are to be filled. आता काय करायचे? 4 पोस्ट आहे. 4 पोस्ट मध्ये ते काय म्हणतात की पहिल्यांदा पहिली आणि लास्ट करायचे. ओके, then second situation ला काय म्हणतात? First 3 are to be selected. ते 3 पोझिशन लाच भरायचे. ओके, then all 4 posts are to be filled. Third situation दिलेले आहे, all 4 posts are to be selected. आता काय करायचे आपल्याला? 6 candidates are there. 6 candidates are there. This would be final. This would be final. The number of posts are 4. Still in the first situation, how many things to be filled? How many things to be filled are the 2 posts? First and last one. First and last one. For finding the number of ways of filling first and second post in order, it is nothing but a number of distinct permutation are 6 things are taken 2 at a time. Obviously 6p2. 6p2. 6 candidates are there and 5 to be filled. 6 things would be there and 5 to be filled. 6P2. 6 candidates would be there and this position and this position is going to fill. So 6P2. So that means 6 factorial minus 4 factorial. So that would be 6 into 5 into 4 factorial divided by 4 factorial. That would be answer would be 30. So 30 times it could be the times it is possible. So first and last position can be filled by the 30 times. 30 times it could be filled. Similarly, second one, third, 3 posts can be filled. 3 posts can be filled. So obviously 6 candidates are there, 3 to be filled. 3 to be filled means 3 candidates we require. 3 candidates we require. Not selection here. We require 3 candidates from the 6 candidates. And we need to arrange that particular things. Arrange these at the positions. Not this problem is not based on selection. This problem is based on the taking some candidates and filling at the particular positions. Filling at the particular positions. So 6P3, 6 candidates are there, 3 to be selected, 3 to be selected, and number of possible ways. 6 factorial divided by 3 factorial. So 6 into 5 into 4 into 3 divided by 3 factorial. So 3 gone in the 4 number, 6 into 5 into 4, that means 120 times it could be possible. So all positions are to be filled. 6P4. So 6 factorial divided by 4 factorial, that means 6 into 5 into 4 factorial divided by 4 factorial, 4 gone, that would be, sorry, it is a 2 factorial, 6 minus 4. 6P, 4 means 6, 6 minus 4, that would be 2. So the answer would be 4P into 2 factorial. So answer would be 360. So 360 times it would be ways that particular post can be filled. 360 ways that particular post can be filled. I am expecting that you should solve the particular questions. Now there is some interesting questions based on alphabet. I think you should, everybody should take a pen and try to solve these particular questions. Everybody should take a pen and try to solve the particular. Certain questions are asked many times, like this word, M-O-N-D-A-Y. I will read out the problem. How many times, how many words with or without dictionary meaning can be made from the letter word Monday? From this particular word, how many words can be made if you need if you arrange the particular alphabets which have a dictionary meaning or without dictionary meaning? So that assuming no letter is repeated, no letter should be repeated. These alphabets are taken 1, 2, 3, 4, 5, 6. 6 alphabets are there. And they say how many words can be possible? How many different words can be possible if you rearrange this particular alphabets? Definitely, if 6 alphabets are there, all are selected, all are taken. All are taken. Means 6 are taken. This would be N, this would be R. Here alphabets are there, are to be taken. Okay, so first question. The 4 letters are used at the time. 4 letters are used at the time. First question, पहला क्वेश्चन है 4 लेटर का बनवाना 4 लेटर यूज कितने अल्फाबेट्स है सेकंड क्वेश्चन all letters to be used at a time all letters to be all letters means what are the alphabets okay and the third one all letters to be taken how many words are formed how many words can be formed. The word the word given is Monday, it could be different. Each time it could be different. How many words can be formed from that particular Monday? If 4 letters are taken, all letters to be taken. And last one, all letters are taken, but first should be vowel. All letters taken, all letters are taken, but the first one O. So how many vowels are possible here? It is a O and I think A. Only two are possible. They have said the first two letters should be OH. First, which position है? Remaining 1, 2, 3, 4, 5. हा जो one position है, it should be OH. मग इकडे मला 2, 3, 4, 5 साला काही प्रॉब्लेम नाही. इथे कुठलेही अल्फाबेट घेऊ शकतो. इथे कुठलेही अल्फाबेट पॉसिबल चालू शकतो. फक्त पहिलं काय लागेल? First should be OH. That is the condition. And now they say how many times this arrangement can be possible. Anybody can solve this problem? I have given the information of the permutation. These four formulas we need to use. Anybody can solve this particular problem? Your reply would be the most important here. I am very surprised that there is a very little interest you are taking for solving this kind of problems, because this is the most important part in aptitude. We just have explained that 25 marks are for the aptitude part. That means you need to score half, nearly half score you can score here in aptitude. Can anybody kind solve this particular problem? Take a breath, take some kind of, just see the particular problem, and is it possible to you, for you or students, you can solve the problems. Okay, forget the things. So 4 letters are taken. How many letters are there? 1, 2, 3, 4, 5, 6. Is there repetition? M-O-N-D-A-Y. More repetitions are there. So I can say we need to arrange, we need to form. So that is definitely arrangement. That is a permutation part would be there. So how many letters are there? 6 letters are there. Forced to be taken and we need to form. So number of words would be 6PR. 6P 4, 6 factorial minus 2 factorial. 6 into 5 into 4 into 3 into 2 factorial divided by 2 factorial. So 30 into 20, so that will be 600. So 600 times it will be possible. So all letters are to be taken. 6 alphabets are there, all to be taken. That means 6 factorial. So 6 factorial means we need to multiply 2 what is a, we need to write the particular position. We need to write the position. So I have given the arrangement. I have given or written the particular arrangement. Six, five, four. This is a 3. 30, 360. Sorry, I've done the 360 and this is a 720. 6 into 5 into 4 into 3. That will be 360. And 6 factorial, that is 720. So now all letters are to be taken, but first is over. So we need to consider this is a one task and remaining is a another task. First, they have said it should be over. So how many overs are possible? O and A. So we can consider either O or A. So how many times it could be possible to fill the particular O or A at the first position? Obviously 2 times. It is possible by 2 times. First position can be filled 2 times. Now remaining positions 1, 2, 3, 4, 5. 5 positions are there. 5 positions are there that could be filled with how many letters? Obviously, one letter is over. One letter we have kept at the first position. So out of the 6, there is a 1 has gone. So 5 alphabets would be there. 5 letters would be there. So we need to arrange 5 letters at 5 positions. We need to arrange 5 letters and 5 positions. That means it is a 5 factorial. 5 factorial. So 5 factorial, that means I can write here 5 factorial, 5 into 4 into 3 into 2 into 1, 6, 24 into 5, that is 120. Okay, so that is 5 factorial means 120 times it could be possible. These 5 alphabets can be arranged by 120 times. This position can be filled by 2 times. Both are same task, not a different task. This is not a filling this first position is a one task and remaining is another task. Both are same task. That's why we need to multiply this. So 2 into 120, that will be 240. 240 times it could be possible. 240 times it is a possible. If you want to write this particular problem, write down. I will take a 1 or 2 minutes break. I think time is also over, but still I am going to take one problem. Okay, one problem I want to take that. I'll write here. How many 4-digit letter can be formed? 4-digit letter. 4-digit letter can be formed by using digits. By using digits 1 to 9. 1 to 9. If repetition of digits are not allowed. Repetition of digits are not allowed. Means only we have to use the digits only once. So we need to just see the problem. What we have to do? 4-digit letter. 1 letter, second letter, third letter, and 4 letters. So these are 4-digit letter or 4 digits. I can problem. They are given the letter, but technically it is a digit number. This is a digit number. So this is a 4-digit number is there. So we need to form a number of 4 digits that we can use only 9 numbers. How many times? How many times the particular numbers can be formed? How many times this particular numbers can be formed. So we can say 1 to 9, 9 numbers are there. We need to one position, second position, third position, fourth position. We have to keep on a 4 positions. 9 letters are there, 9 numbers are there, rather 9 numbers are there, and we need to keep at 4 positions. 9 numbers, 4 positions. That means obviously it is a permutation 9p, 9pr. So that is 9 factorial divided by 9 minus 4, 5 factorial. That would be 9 into 5 into 9 into 8 into 7 into 6 into 5 factorial divided by 5 factorial. So we need to multiply 9 into 8 into 7 into 6. So 72 into 42. 72 into 42. So obviously, if you have a calculator, you can use directly. So that can be possible. 3024. 3024 means this letter, this number can be 4-digit number can be formed how many times? 3024 times. 3024 times can be possible. If 9 letters to be we have to take, no repetition will be there, and all to be selected. So we can do this kind of problem by physically different ways. This is the first position, second position, third position, fourth position. First position, how many letters can be possible? How many letters? 9 letters are there. So it could be, we can keep any letter here. It could be, we can keep any letters. So 9 letters are there. We have to fill out the first position. It could be done by 9 times. Here, now second position. How many letters are there? Now 1 letter is gone here. So only 8 letters are remaining. Now at the third position, 2 letters are gone. 9 letters are available. Out of that, 2 letters we have kept at the first and second position. Now 7 letters would be there. Now at the last position, we have to keep, how many letters are there? 9 letters are there. 3 letters are over. 9 minus 3, 6. So 6 letters are possible. And all we have to multiply because this is a same task. 9 into 8 into 7 into 6. That means the again answer would be 3024. When it is possible, when they have said purposefully, they have said all, there should not be any repetition of the particular numbers. Suppose all alphabets are, we can repeat. So repetition are allowed. Suppose we have used the one number at the first position, it could be used at the second position, third position, fourth position. Then it could be possible 9 again second position, all letters are available. Even if it is used in the first position, again it would be available 9, again here 9, again here 9. So how many times it could be possible? 9 into 9 into 9. So that is 9 raised to 4 times it could be possible. Okay, we'll stop here. Definitely on a Monday onwards, I will make an arrangement such a way that we will take a lecture continuously. So each session we are going to clear a certain concept on aptitude, and we will take a lecture. So okay, thank you. I am closing the session.